What is work? When you think of work, what comes to your mind? Maybe you think of working like a job. Or maybe you think of work as doing some type of schoolwork. Based on our world understanding, we can infer work to be action of doing something or completing a task. But what is work in physics? Work is defined as the transfer of energy from one system to another through the application of force. Work is equal to the force multiplied by the displacement the particle is moved of the point of the application of force, cosine theta, where theta is the angle between the force and displacement vectors.
Applying force on an object does not always result in work being done. For example, let's say that there was a car that you wanted to apply force to or push. You push as hard as you can, but you cannot move the car. Since the car doesn't move, there is no work being done on the car. Now let's say the stick man did successfully move the car. Since the object is displaced by a force, work is being done on the object. In this case, the object is the car. So in order for work to be done on an object, there has to be a displacement of the object.
Energy is a physical quantity often defined as the ability to work. Energy exists in form like thermal energy, light energy, mechanical energy, kinetic energy, and potential energy. Energy in the universe is fixed. Energy can be transformed or transferred, but it cannot be created or destroyed according to the law of conservation of energy. Kinetic energy is the energy related to motion of an object. It is in written form as K equals 1/2 m times v squared, where m is mass and v is velocity. Potential energy is a measure of energy that is stored within a system and is able to be converted into other forms of energy. Types of potential energy are gravitational potential energy, elastic potential energy, and electrical potential energy.
Gravitational potential energy is the potential an object has to do work as a result of being located at a particular position in a gravitational field. Elastic potential energy is the potential energy stored by the deformation of an elastic material, such as a spring. Electric potential energy is the energy that is needed to move a charge against an electric field. Example: as the bicycle goes further up the hill and further from the ground, the potential energy increases. As the bicycle goes down a hill, the potential energy decreases. The potential energy of the bike is converted to kinetic energy as it goes down a hill.
Work energy theorem or work kinetic energy theorem describes how energy is transformed and transferred in systems. A system can be an object, a collection of objects, or a region of space. The work energy theorem is given by the equation W equals the change of kinetic energy, where W is work and the triangle K is the change of kinetic energy.
The work energy theorem states that if a system's total work is positive, energy is being added to the system, increasing the system's kinetic energy. If the total work is negative, energy is being moved out of the system, which causes the kinetic energy to drop. As stated earlier, a system can be an object, a collection of objects, or a region of space. Types of systems in physics are isolated systems and non-isolated systems. Isolated systems. An isolated system is a system that is fully cut out from its surroundings and cannot exchange energy or matter with its environment. The total amount of energy in a system is constant. If the total amount of energy changes, it must have transferred across the boundary through some means of energy transfer. Non-isolated systems. A non-isolated system is a system that isn't completely isolated from its environment, or just the region surrounding the system. This means that the total amount of energy in the system can be changed over time. So far, we've looked at work as a way to transfer energy into a system, but let's look at some other ways to transfer energy. Mechanical waves, heat, matter transfer, electrical transmission, and electromagnetic radiation. Mechanical waves. Mechanical waves are a way to transfer energy by allowing disturbances to move through the air or another medium. Ocean waves and seismic waves are examples. The sound leaves the speakers of the alarm clock through mechanical waves. The difference in temperature between a system and its surroundings acts as the driving force behind the energy transfer mechanism, heat. Heat transfers to the handle of the spoon through the heat transfer mechanism. Matter transfer. Matter transfer involves events where matter physically crosses a system's border while carrying energy. Energy matter enters the automobile from the gas tank through matter transfer. Electrical transmission. Electrical transmission is the process of energy transfer in or out of a system through electric currents. Energy enters the blow dryer through electrical transmission. Electromagnetic radiation. Electromagnetic radiation describes electromagnetic waves like visible light, microwaves, and radio waves crossing the boundary of a system. Energy leaves the light bulb by electromagnetic radiation.
We all know the basic meaning of a force, a push or pull, but let's go deeper. Force is the cause of changes in motion, where m is mass and a is acceleration. Force has both magnitude and direction, making it a vector quantity.
The forces discussed in this chapter are conservative and non-conservative forces. Conservative forces. Conservative forces are forces that have the property of the work done by the force on an object moving between 2 points. In short, this means that the work done by a conservative force depends only on the initial and final positions of the object and not the specific path it takes between these points. Examples of conservative forces include gravitational
Done by a
force
constant
and spring
force is given equal force time
Here's an
displacement
example of
cosine theta.
gravitational force.
Work equals force time displacement.
The ball falls to the ground because of gravitational force. The relationship between conservative forces and potential energy is that the work done by a conservative force on an object can be stored as potential energy. This means that the work done by a conservative force can be used to increase the potential energy of an object. Non-conservative forces. Non-conservative forces are forces where work depends on the path taken. Work done by a non-conservative force either adds or removes mechanical energy from a system. These forces have no potential energy. An example of non-conservative forces include friction and drag.
We understand the concept, we can circle back to work is a scalar, but it is defined by two vector quantities, force and displacement. How does this work? Because of the dot product. The dot product or the scalar product is the mathematical equation used to define the two vector quantities as a scalar quantity. It is the product of the magnitudes of the two vectors and the cosine of the angle between them. A times b equals the magnitude of a and b cosine theta, where a and b are the magnitudes of vectors a and b.